Everybody from the East Coast, and good morning to the West Coast from an absolutely beautiful Charlotte, North Carolina. My name is Kurt Luke, and I run the Business Intelligence and Analytics practice for Pactera. I will be the moderator just for a few moments to kick off this webinar. So welcome to the Big Data webinar with the title of Utilizing Big Data to Predict Customer Behavior. This is another webinar in our series of business intelligence presentations. Go ahead and go to the next slide. All right, so as a quick introduction to Pactera, one of the largest companies that you may not have heard of, we've got about 24,000 employees across the globe with 35 offices around the world. We offer a wide variety of services to the market, including CRM, mobile, and of course business intelligence. Business intelligence and big data is an area that we are investing very, very heavily within. So let's go to the next page. All right, I'm going to introduce Tom Kersnick, who's going to take the rest of this presentation. Tom comes to us and runs the big data practice for Pactera within the U.S. Tom, frankly, was in the big data space before big data really hit the mainstream. So, Tom?
Yes, hello. My name is Tom Kersnick. Today we appreciate your attendance all together and sincerely hope you gather some very valuable information and insights from our presentation today. This is a very exciting topic on utilizing big data to predict customer behavior. We're going to spend some time in this webinar on 5 ways big data can provide intimacy with your customers, how to create a successful predictive analytics strategy, and last but not least, making data accessible to non-data scientists. So as customers continue to seek out individualized purchasing experiences, companies are beginning to realize that their big data initiatives must be optimized in order to provide the personalized level of service that customers demand. Here are a few initiatives that can help ensure a customer for life. Spotting real-time shifts in customer behavior. This will facilitate stronger connections between customer, products, pricing, promotions, and sales. If a promotion does not yield the purchases for which the company was hoping, what it can do to increase sales with a different promotion, to discover meaningful relationships and trends within its data, companies must learn how to best acquire, analyze, and act on this new information. The data can assist an organization in decisions to bundle services and solutions and determine pricing and proper packaging. Another one is data categories. Organizations typically divide data into 2 categories, transactional and sub-transactional data. I recommend focusing on the sub-transactional data or clickstream-based data to identify patterns in user intentions. This data helps your organization make useful predictions about customer behaviors. Next is pricing models. Tie the usage to pricing and better match customer behavior to pricing altogether. Using big data solutions, companies can offer services at prices and packages that align with customer actions while offering the ability to upsell based on those actions in parallel. Next is behavior-based customer offers. Track user clickstream behaviors. Also showing real-time offers to customers based on specific behavior patterns. This architecture allows to create offers and monetize them immediately to drive more revenue. For example, that a well-known travel site will do to increase revenue. They will constantly adjust their prices based on sales of a specific route in real time based on users' interactions and reactions. Last but not least is preventing customer churn. Customers lost to churn need to be replaced, and that's very expensive. Keeping customer acquisition costs at less than annual recurring revenue is important within today's products. Sub-transactional data allows your organization to identify when customers begin to use your solutions less frequently or when they're about to make specific mistakes using your products. Overall, analyze this information and put it to good use by fine-tuning the user experience, which will lead to more engaged customers. So creating a successful predictive strategy, the best solution I can provide is try to reduce to a classification problem. Using machine learning within existing tools to get an answer, a proper big data solution architecture can help in this discovery. Next is extract defined and variable features associated. Look for the golden nuggets in your unstructured data that you can extract. Think of it this way: what am I not tracking? Is there more factors that can be analyzed that can determine potential customer behavior? A great example is capturing data in the millisecond category to determine accuracy. Next is define what you want to predict. One of those more detailed approaches in time series, as mentioned earlier, allowing forecasting, risk and probability, and proper recommendations. What questions you're not currently able to answer? Next is creating a training set. Gather as many classified examples as you can get. For an example, user X visited 5 pages and spent a total of 4 minutes. There's a lot of interesting information there, especially when you track that over a month's time or even a year. The next is execute any existing classification algorithms that you may have. Try to predict what a non-classified user did, giving just his or her features alone. A short list of some algorithms that you can use for this is SVM. It's not really that intuitive, but is considered by many the best classification algorithm available. Next is K-nearest neighbor, very intuitive and simple to program. And also the training set can be iteratively increased easily, but is usually a bad decision if the number of features is very high. Next is decision tree algorithms. Allows very fast classification, and the resulting tree is intuitive and readable to humans. And remember, the end result of this strategy should always be considered as how much the algorithm was right and how much was it wrong, and how. Predictive model framework. So the framework involves data, features, machine learning algorithms, and prediction output. What data use, what features, which algorithms, and recommendations. Building predictive models is the bread and butter of applied data mining because you can compare using a model with your current best practice. It is relatively straightforward to monetize, and the added value of data mining increases that tenfold. This calculation should be a default part of your process, not just to support business decision making, but also to foster buy-in for your work. Make sure you understand the modeling objective. Think of model building as working backwards. Start with the desired outcomes and then work your way back to what needs to happen in order to pursue those outcomes. There is no use in building a great model for the wrong problem. Getting modeling objective wrong is the single most occurring regret in the post-mortem. Get a good head start with a good briefing ahead of time. Get a feel for your data. After you've achieved clarity on the modeling objective, it is often a good idea to first play around with your data sets. You need to know which variables to expect in your model. Investigating new and/or derived variables is the most powerful way to look for big improvements in your prediction accuracy. Next is compare a range of algorithms. The algorithm people are most familiar with always gives the best result. This, of course, has less to do with suitability of the algorithm than with the skill level of the analyst. When you develop the habit to compare a range of algorithms, you keep an eye for surprises and maintain a least working knowledge in multiple approaches. And finally, always include an explanation and recommendation with your prediction. Not only for just the sanity check, it will foster buy-in and can possibly transform the business. Predictive modeling is always a continuous cycle. Initial investigations, what data is available, what is the overall outcomes, deciding on the type of model required for this. Getting the data ready, asking the right questions about data quality, determining the right type of model, which models are working, which ones should be thrown out. It's a continuous cycle. Then last is checking the model. And as you can see the arrow, you're going to start again. always fine-tuning your model. The predictive analytics big data flow is it's listed here in 4 steps: capturing and storing data, processing, deriving insights, and making insights actionable. And last but not least, rejecting the bad data and the wrong insights. Predictive models often perform calculations during live transactions. For example, to evaluate the risk of opportunity of a given customer or transaction in order to guide a proper decision. Big data and predictive analytics can be combined together in the operational environment. By focusing on operational decisions, we can put big data to work, using it to drive predictions that improve our ability to make good decisions at the operational level. With advancement in computing speed, individual agent modeling systems can simulate human behavior or reaction to given stimuli or scenarios. Having the right solution architecture in place is key to our success. Here are some steps to follow within your solution architecture to gain new insights. Start with a small data sample. You don't need the full width and depth of your data to find interesting stuff. Start small. It saves you a lot of technology headache at the start for sure. The important words here are simple: actionable and understandable. Check if the model gives you any practical insights. Explore the model, find its gold or not, and discard it. Using the model to generate predictions and see if it can improve your company's performance. Put the model to action. Find a playground in your company to test and measure the changes in churn, conversion, risk, or whatever you want modeled. Check how more data can improve your model. You can add data in 2 ways. Simply add more data points to the same data set, or you can add more features to the data set. New pieces of information to enhance the model and find new relationships with possibly better performance. In spreadsheet terms, you can add more rows or more columns. Always split the data sets into data sets, thus allowing you to take a deeper dive into your predictions. Usually what happens in this case is that when you have a massive data set, it's always wise to parse your data sets into smaller sets to make sure that your predictions are coming across accurately. Check if this is more sophisticated model beats the previous model. So what I'm saying here is that maybe the model you just created the first time or the X time isn't going to be as great as the next one that you're going to do. Again, put it to action and see how it performs. Does it improve the previous results? Most likely it does so. Iterate. The secret here is to try to multiple models to see which one gives the best results at this point in time. Continue to iterate to find the best fit. And finally, actionable insights. Now that you've seen some successful implementations of your predictive models, you're much better equipped to determine proper outcomes. Getting started with big data is just all about actionable analytics. Next, making big data accessible to non-data scientists. Many think that the explosion in big data will create demand for data scientists able to slice and dice data to guide more informed decision-making within the organizations. Others go a step further, that a chronic data scientist shortage will hold back the full potential of big data. A proper scalable solution architecture will not only allow growth within your organization, but ease of use over time to solve some of your biggest revenue-driving hurdles. For years, the BI and data analytics conversion was framed around how to aggregate massive volumes of data and then unleash the data scientists to find the value. Today, despite the information deluge, enterprise decision makers are often unable to access the data in a useful way. Here are some interesting outlooks to come our way for the non-data scientist. So one is accelerating natural language capabilities. And laying out several predictions for big data and data analytics in the coming years, the research firm Gartner forecasts that by 2016, 70% of the leading BI vendors have incorporated a natural language and spoken word capability. Improving natural language queries is essential to consumerization of big data, as it is better enables everyday business users to ask questions of their analytics tool in an intuitive format, such as text, voice-enabled, etc., and receive the most relevant and meaningful visualization results. The next is look smart and ask very little of the user. So as you can see in the up-and-coming releases of products, users now expect the answer to be presented via visualization, and they expect to be able to interact with that visualization. It's more than a picture telling 1,000 words. It's the picture becoming the interaction. Next is create a social learning layer. By building a social learning layer into analytics tools, user behavior can be learned by the tool, so it can anticipate queries and be trained to specific needs of each user. By making the tool as seamless as possible for business users, there's a less chance the tool will waste time, resources, or deliver different results than what the user is actually looking for. Next is deflate big data. An enterprise should start with a small set of users that it believes will experience the most immediate value. Next is focus on the right kind of mobility. Today's big analytics platform must consumerize the user experience by removing spreadsheets and reports and place the power of analytics in the hands of users of any level and analytics expertise. This consumerized data analytics experience must enable mobility on any smartphone or tablet device with complete flexibility on how the data can be visualized. It is the flexibility for visualizing data in real time on mobile devices rather than just making massive volumes of data accessible to mobile users. That will help data analytics providers realize the most from their mobile investments. A consumerized big data experience is in sight for enterprises. As long as data analytics providers remain focused on features and functionalities that ultimately will matter most to business users, big data analytics is leading the charge to reinventing enterprise applications, bringing our consumer-level expectations to our everyday work experience. Next, we're going to give a use case on an online travel company in regarding predictive analysis. So this use case is involved in flight cost by variance determination. For this large online travel company, data feeds, flight cost is one of the algorithms methods being used to increase, decrease revenue based on page views, consumer marketing, and time spent on a particular one-way or round-trip flight by a consumer. The goal is to provide not only alternatives, but increase, decrease costs while other consumers are also viewing the same flights. This is determined by sales from all related airlines and competitors during the flight availability. The method can be extended to use other sources as well, based on the architecture shown. So the idea here is to take all the HTTP logs, partners, and all the custom marketing information, including social media, into a real-time in-memory solution. The outgoing effect is to provide it into your front-facing web applications, Hadoop, your current ecosystems in RDBMS, as well as your mobile applications to the end user. So in the solution architecture shown, the in-memory solution processes views, marketing, customer behavior, time, and competitor results to derive an increased or decreased price for a given one-way or round-trip flight. This allows this travel company to determine the proper pricing based on these measures within algorithms. The architecture shown also allows this travel company to try other predictive models at any given point in time to see if one model outperforms the other. They could be utilizing similar measures and outcomes as well as new derived measures from their predictive models. Overall, this is a win for the travel company. Never losing revenue from their original bread and butter model they always apply, but they'll also be able to try new models at any given point in time. Fascinating, right? Definitely to me. As you can see in the outgoing destinations, this provides consistent results in all platforms, allowing a finite understanding of how the travel company is generating results overall. The solution can provide endless results based on predictive models that can be applied in real time, any day, any time, any millisecond. So how can Pactera help with big data? Pactera offers a complete lifecycle solutions within your organization. We offer a free 4-hour executive and technical workshop within your organization. We just ask you to fill out a one-page questionnaire to help us understand what your expectations are. The executive workshop entails strategy, planning, and your current and future goals. The technical workshop is a deep dive involving end-to-end management and a proper solution architecture based on your current and up-and-coming goals. Once the workshop is complete, we will provide you an assessment of the outcome. We also offer 2 to 4 week proof of concepts to ensure your project is put into action. And finally, we offer full life cycle in the following areas. Benchmark and monitoring. We'll benchmark and monitor your big data solution for you and help you come up with best practices. Integrations and migrations. If you want to coincide with your current ecosystem and migrate from, let's say, log files, old tapes, that type of thing, we'll be happy to assist. Implementation and architecture, best practices in solution architecture. Project management, both business and technical project management. Analytics, as mentioned in this predictive analytics webinar, as well as segmentation and other types of analytics that you may be interested in, as well as reporting. Well, I'd like to thank everybody for attending the Pactera's webinar on utilizing big data to predict customer behavior. I hope you gained some insights from this presentation. Are there any questions? Okay, here I'm receiving a few questions here. I'll just be happy to go through. So you mentioned that a chronic data scientist shortage will hold back the full potential of big data. Is that really true? Well, absolutely not. There are a lot of amazing visualization tools coming our way. I believe the future is all about interaction. It's all about the algorithms and the models that we utilize that will take place in the visualization portion. Next is, do we have to provide you with in-house hardware to conduct the workshop, proof of concept, as well as a project life cycle? Absolutely not. We offer cloud services as well as a right-shore model. We can work with you to fit your needs and take your organization to the next detailed level. And here's another one. You mentioned that predictive modeling is a continuous cycle. What if your data is not ready and it's completely unstructured? Well, my suggestion is utilizing proper programming techniques that will assist in parsing portions of your unstructured data, thus allowing structured data within your models. This is when my data janitor role hat comes on, and it comes real handy. It allows me to take that really monstrosity of unstructured data and format it into where I can utilize it in my models that either A, I already have, or B, that I'll be creating going forward. And remember, if you don't get it right the first time, just start over. Well, thanks again on behalf of Pactera, and I really appreciate your time. If you do have any follow-up questions, feel free to contact us.